This is question number 4. A layer of water flows down an inclined fixed surface with the velocity profile shown in figure 3. Determine the magnitude and direction of the shearing stress and the water exert on the fixed surface for U equal 2 meter per second and H is equal 0.1 meter. So in this situation, the condition is totally different from what we learned previously in the theoretical part. So in this situation, we only have a surface at the bottom here, but at the top here we have a liquid and there are no any moving plate at the top. So how we could calculate the velocity here? So we could assume like this. So at the bottom here, so we have a molecule, and this molecule has will feel no slip condition. So the velocity at the bottom is remain 0 meter per second, and then the next molecule here will move at certain velocity. It's become faster and faster, and until one height, at certain height, the velocity will reach the maximum velocity. So and then we change the terms for the maximum velocity here with the capital U. So the capital U means that it is the maximum velocity of the flow. So and then the small u here is the various velocity for each molecule and in this region. So and then sometimes we will have the equation or the mathematical expression for the velocity profile. So in this term, it is written as u over u equal to y over h minus y square over h square. So this is actually the ratio. If you see the terms here, this is the ratio of small u, mean the velocity inside the velocity distribution, and the capital U means the maximum velocity in this problem. So the u over u means the ratio of the varies of specific velocity at a specific value of h, because you could see in this equation we have value of h here, means the location of molecule that we could find the velocity. So this is the answer for question number 4. So you need to remember that the equation for shear stress is tau equal mu du dy. So and then normally in last tutorial I said that du here means the velocity difference of the system, and the y here is the gap or the height difference in y-axis. But if you see the diagram here, so it is not mentioned any value of this velocity, so we cannot make any deduction here. So and then what we need to do is, so the term du dy here is actually the differential form of the velocity. So means that if we have the velocity distribution like this, so we could rearrange the equation become like this one. So and then we could differentiate this value, and we have du dy is equal to 2u over h minus 2yu over h square. So and then we need to put a condition for this situation. So normally we will use y equal to 0. Why we use y equal to 0? Because at any condition on the surface here, the shear stress is the maximum one. So in any calculation, we must calculate the maximum value of the shear stress. That's why we always use condition of y equal to 0. So what we do is, so after we differentiate the velocity profile, So we substitute the value of y equal to 0. So we substitute the value of y equal to 0 here. So and then we could say the du dy at y equal to 0 is equal to 2u over h. So and then we could solve our problem. So let's say the shear stress here is tau mu du dy. We substitute the value of mu. We substitute the value of du dy as what we get here. So and then we calculate, we could find that the tau here is equal to 0.0448 Newton per meter square.